Let's see, are we on? Yes, we are on. At least some of you made it back. Those are the ones who realize that the schedule actually doesn't tell you when we're going to finish, right? You'll notice the next thing on the schedule is when it starts tomorrow. So we'll just keep going until then. And you'll just have to sleep in, right? That's why we're all here. Okay, so we talked about LDAP. The next authentication method that I'd say is on the order of security. I'd say, as I said, the peer is probably the most secure authentication method. The second most secure, if you manage to set it up properly, is GSS API, or GSS as the shortened version that we use for it. In reality, that pretty much always means Kerberos. And Kerberos turns out to be a very good single sign-on protocol. The big difference between Kerberos and LDAP is with LDAP, you have a single password. Right? You type the password in, you only have one central password storage. But you still type the password in every time. With Kerberos, you don't. You actually get single sign-on. So what happens is you initialize, you sign into what is known as the Kerberos realm, which typically happens when you log into your workstation or log into your laptop. And you get a Kerberos ticket from the Kerberos system. Then when you connect to Postgres, your system will transparently take this ticket that it received and send that ticket to Postgres, saying, hey, here's who I am. Postgres will then take that ticket and has a trust relationship with the Kerberos server saying, oh, this ticket says you are this user, so I'll accept that as being the truth. And Kerberos was designed to run over the open internet, so it's designed to actually be a secure authentication protocol. So all the Kerberos communications in itself is encrypted and it's hashed and it's authenticated at every stage. The advantage is this, you get no password prompt, you just get pure transparent login. You type PSQL to a remote server, it logs you in fully secure without you having to do anything after you set it up. So as a user, it's very good. I find this to be an excellent choice if you're in a scenario where you have fat client applications, so actual client level applications. If you're writing a web app, you might want to consider using Kerberos between the client and the web server, but not necessarily between the web server and Postgres. Between the web server and Postgres, just using something like Md5 is perfectly fine. Now, Kerberos exists in a lot of environments, but if you count probably number of nodes, definitely number of deployments, the most common way to get Kerberos today is Active Directory. Like if you have an Active Directory environment, then you have Kerberos whether you know it or not. And Postgres will work very nicely in this type of environment. And you can use Postgres on Linux, for example, working in an Active Directory environment, so that your clients can get transparent logins and will just use the Kerberos system that's inherent in Active Directory to perform all the secure logins. Now there is in Postgres also an authentication method called KRV5. Is in the past tense, it's been deprecated for a long time. The fact it has now been removed. So if you are using it somewhere, you should upgrade that to GSS. The real difference is KRV5 is sort of raw Kerberos protocols directly on the TCP socket, managed by Postgres. GSS API is a standard protocol that does the same thing. So we switched to a standard protocol for getting better platform support and things like that. But functionality-wise, it is the same. It's the same kind of Kerberos. We just wrap it in a standard protocol, which helps. Now, Kerberos is in a few ways similar to SSL in that it does mutual authentication. You can use both of them because Kerberos in Postgres does not provide encryption. Again, there is actually a patch being reviewed right now to add Kerberos encryption into a future version of Postgres. But right now, if you need encryption, you need to use SSL. But you can use Kerberos for authentication on an SSL connection. Now, Kerberos uses something called key tabs, principals, and realms. Awesome terms, right? Now, key tabs is basically a set of encryption keys. Unlike SSL, which uses public key cryptography with certificates, Kerberos uses shared secret key cryptography. So you copy crypto files around. That's the downside of Kerberos, is the setup cost of managing the crypto keys. But it basically, a principal in Kerberos is basically a user. And a realm in Kerberos is basically a domain. And Kerberos is very built on top of DNS, so if you don't have working DNS, you will never get working Kerberos. And if your realms don't match DNS, you can make it work, but it's going to be painful. Right? But at the basics, you can make it work. And it does mutual authentication. So basically what happens when a client connects is a client authenticates the server, and then the server authenticates the client. It's very similar to SSL. That means that each server also has a principal in the Kerberos system. So basically each server has a user. Now the default of Postgres is that this user will be named Postgres / and then the FQDN of the server. You can configure this. Again, the default is Postgres. This is case sensitive. And if you are actually using something like Active Directory requires this portion to be uppercase. It's one of the few cases where Windows is the one that's case sensitive more. But it needs to be uppercase if you're doing that. If you're on a Unix system, the default works straight through, but if you have an Active Directory, it needs to be set to uppercase, and you need to do that on both the server and the client. Now to get this working, you need this thing called a key tab, which is just a file of crypto keys. The Postgres server needs a key tab. It needs to be readable by Postgres, but it can be a Postgres specific key tab, or you can use the system-wide key tab that your server has. Postgres will use any principal that's in that file, as long as it matches what the client says. So if the client says, you know, Postgres / database1.domain.com, there has to be a principal for that exact thing. Postgres / database1.domain.com needs to be in the principal file. There can be other keys in the file as well, but this one needs to be there. And it's case sensitive. Now that key tab is generated, you get the key from the Kerberos server and copy it to your Postgres server into this key tab file. And that's how Postgres learns to know about it. Then you have principals for users. And a principal for user in Kerberos is user@domain.com. So the service principal that we use is Postgres / server.domain.com. The user is going to be user@domain.com. So you know, Magnus@domain.com. Postgres can match this with or without realms. The default in current versions of Postgres is to match it without. This will change. The default will change. And the project went out, I think it was late last year or early this year in one of the minor releases, saying we do, as of now, strongly recommend that you always include the realm in your matching. The problem otherwise, if you have a multi-realm, so multi-domain Kerberos setup, and the same user exists in more than one realm, you can transparently log in as the wrong user, which is probably not great. Now, you might only have one realm or one domain today, but who knows what you're going to have a year from now. So always matching with the realm is the secure choice. So make sure you do that. And then what you can do is you can remove the realm again using something called pgident.conf, which I will show you in a moment. So you can also actually create users inside your database that are called user@domain.com, but normally you want them to just be called user in this case. So we need to take it off again. We want to put it in there when we perform the validation. What this means is, this is the important parameter. We say the authentication type GSS, then we say include realm equals 1. That's the one that you should go put there, if you don't have it already. And then we add a mapping, saying map equals GSS. Again, I'll show you that in a minute. That just tells you how to handle the different realms. We can also restrict it specifically, so we can do that instead. You can, for example, say include realm equals 1, and then curb realm equals domain.com. That means that any user trying to authenticate with a realm different from domain.com will just not be allowed to log in. So if you actually use curb realm equals something, then you don't really need to use the include rel, but it also doesn't hurt. Right? And it's more secure for potential things you might end up doing in the future. So treating the user principal as the full user@domain.com is the secure thing to do. Because you might have multiple rounds. Or you might gain multiple rounds. But once you have that set up, it's actually, it all just works. The hard part about it is setting up the Kerberos side, like on the Kerberos server side. But once you've that done and you just want to add Postgres into your existing Kerberos environment, it's pretty simple to do. This is all you need to do. You need to generate the principal, you need to configure this line. Obviously the client needs to be a part of your Kerberos environment as well. But once you have that, it just works. Another authentication type, per the question from earlier, is we support radius authentication, which is another one. It's very trivial. Radius is the remote access dial-in user system, I think. It was written, back in the good old days when you wanted to go on the internet, you called up modem that was probably in like a tray of 100 actual standalone modem things. It's designed to be extremely lightweight. It's a single UDP packet protocol. So basically, it looks like a password to the client, again, just like LDAP. And when Postgres gets the username and the password, it packages them up, it encrypts them with a shared secret, and it sends a single UDP packet to the radio server. And the radio server sends back a single packet saying either yes or no. And that's basically it. But it's a password to the client, so it's a clear text. So you should only use it over SSL connections unless all your users are local. Now this is a very common thing for OTP solutions today. If you have one of these little key fob things that generate numbers, random things from RSA or Vasco or something like that, pretty much all of them ship with support for radius out of the box. So you can just plug this into that, and now you have a one-time password to log into the database. There is also actually one of the hidden gems that Microsoft shipped you in Active Directory. They actually ship a very good radius server. So if you're considering using LDAP to talk to Active Directory, you might actually want to consider using this instead, because in that radius server you can create all sorts of policies of who is allowed to log in during which time and things like that. Obviously you can do that with any radius server, but in particular LDAP to Active Directory can be unnecessarily complicated. So it's very trivial, and setting it up, it's just, we said radius server, give it an IP address, radius secret, that's the shared encryption key that needs to go on the radius server as well. And then it just works, as long as you set up the radius server, which hopefully worked. Now you can make it a nice circular dependency by having the radius server being backed by a Postgres database, storing the users in a table. If you make those the same database, interesting things can happen when the radius server can't log into itself. Not that I would have ever tried that, by mistake or not, right? The final authentication method I've mentioned, I've been starting on it before, is certificates, which basically maps a client certificate to a login. And it always uses the CN value. So as I mentioned before, we ignore the rest of the certificate, except validating that it's trusted. But we look at the CN value. So we can read this certificate in any way if you write your own application, as long as you can feed the certificate structure into the OpenSSL library. You can do it whatever way you want, and Postgres will just use it. The normal thing is we use PEM-encoded text files, which is, again, it's what OpenSSL uses, and we're on top of OpenSSL, so it's what we do. Yes?
I have a question.
Do we have just a second for the microphone?
Okay, I have a question. Why do you ignore subject alt name section in OpenSSL?
Why we don't support subject alternate name?
Yeah.
Because you haven't upgraded yet. The new version of Postgres will support subject alternate names. The one that's coming out sometime this autumn. So I guess the answer is because we haven't done it yet. But it will be there. So again, to make it work, the server must have the CA certificate. If you are using a CRL, which you probably should be, then the server must have that too. And the client must have the CA certificate. And if you're using a CRL, which you probably should be, the client must have that too. But as long as you've got those parts surrounded, the certificate login works just like the GSS or whatever. As long as you have the certificate, you just log in immediately and you're done. I've actually, as I mentioned to someone who asked me a question here right after the other talk, I find this is actually a very good choice if you're doing like cross data center replication, for example, because the Postgres replication connections supports all the same types of logins as the other ones, and certificate is a very secure login that makes it very easy for an automated process being on the other end. Something like GSS API is excellent if it's a user sitting on the other end, but not necessarily if the other end is also a server. But in this case, you generate the client certificate, you store it securely on the replication standby, and have it use that to log into the master. You get the authentication, you get an encrypted connection. You can optionally turn on compression in SSL if you want to get all of that stuff for free. So I come to use this quite often actually for server to server or service to server login. The fact that we don't really have a very nice user interface to it, it deals with files and engines, means that it's not very user-friendly if you have an end user logging into the system. But for a server or a service logging in, it can be a very convenient way of getting something that's really, really secure. Obviously, if someone steals the certificate off the standby, now they can log in. But if they could do that, they could just steal the whole database off the standby. So you're sort of lost already in that case. So it's a very useful thing for that. Now, one thing that's common across all of these external systems is that sometimes we have different usernames. And for this, we have a feature called username mapping. It applies to any external username or any external authentication system where the username is provided by the external system. So it's peer, it's GSS, and certificate of the ones that we've talked about here. So the giving thing here is for peer, Postgres goes to ask the kernel who is over there. For GSS, it goes asking the Kerberos system who is over there. For example, for LDAP, Postgres gets the username from the client and sends it to LDAP. Username mapping does not apply when that happens. It only happens when Postgres goes out and asks for the username from the external system. Now what it lets us do then is say, if the user is called something in the LDAP, sorry, not in the LDAP, in the Kerberos system, then that user is allowed to log in as a different username in the database. This can either be a static mapping, just saying, user Magnus is allowed to log in as Postgres. Or it can be dynamic mapping, which is what we often use with things like Kerberos and certificates, where you can say, anything at domain.com is allowed to log in as something. We do that level of mapping. So to do username mapping, we add a parameter. This is another example out of our HBA file, where you see we've got peer for locals, we got GSS, and we got certificate. And then we add another parameter here that says map. In this case, we say, for peer connections, use map equals local. For GSS, we use map equals GSS, include realm equals 1. Because I just said you should always say include realm, right? And then we say cert map equals cert. Now map names are anything you can make up, right? Well, I suggest you stick to ASCII, but it might work. Someone should try that in Cyrillic and let me know if it worked. I think it might, but I don't actually know. But it's a short string name that corresponds to the name of the map in the mapping file. Now Postgres has the so-called third config file that most people don't edit. It's called pgident.conf. The reason for that name is that back in the days, the only authentication method that supported username mapping was ident, which I didn't even mention now because you shouldn't be using it. It really should be like pgusermap.conf or something now, but it's not important enough to break backwards compatibility for it. So it's called pgident.conf, and it contains your username mappings. And it's basically a 3-column text file, where the first column is the name of the map. So what we have here is for, local, that's the name of the map that corresponds to local that we had up here in HBA. And then we say the user root in the operating system, because this was peer. So if the process running as root tries to connect to the database, that user is allowed to log in as Postgres. So he doesn't have to do an S, I mean it's root, he can do whatever he wants, but he doesn't have to SU over to Postgres. Now one important thing to notice here that I should have put in my example, but I didn't, is that if this is all you put in there and you don't put anything where these dots are not literal dots in the file, that's more lines, right? If you don't put anything else in here, the user Postgres can no longer log into the database. You actually have to add a local Postgres to say that the user Postgres is also allowed to log in as the user Postgres. It's a common mistake, I'll tell you that. I make that mistake all the time. So you need to add that. Now we have another map. Obviously the idea here, which is also, doesn't entirely fit on the slide, is that your local map usually has more than one row in it. Your GSS map might have more than one row in it, etc. So the next map we have is GSS, which is the one that came from here, right? We have map equals GSS, include round equals 1. And this is how we then strip it out, because what we also support here is regular expressions. So what we're saying here, by starting it with a slash, that means that this is a regular expression. Start of string, capture group, this is standard regular expression. Capture anything at domain.com, end of username. And we use a back reference here saying, okay, so if whatever was matched here gets put over there. So user Magnus at domain.com is hereby allowed to log in as the user Magnus in the database. I don't need to create all my users with at domain.com. I could also say that all users at finance.domain.com is allowed to log in as the user finance without using a backtick or something like that. And a similar thing then in this example for certificates. A common thing in certificates is people tend to put CN equals into the CN field, which is kind of, so basically what's in the certificate is CN equals Magnus. You have no idea how many times I've seen that. I don't know why, but it seems to be a very common mistake. And you can just, again, you strip out the CN equals and you say whatever is left over, user can log in as that. It's very common that you'll want these once you start using these external setups, because you might not want to import whatever naming standard your certificate issuing people have. Another common one there is people put the email address in the certificate of a client user certificate. You can create every user with their username being their full email address, right? But you probably don't want to do that. And there is a length limit on it in the end. I think it's name length, which is 63. I think that's how long we limit a username by default. So give people shorter email addresses or use something like this. Obviously the length of this can be pretty much anything as long as you map it into something that fits in a regular username. So PG indent is one of those things that I found a lot of people have been using Postgres for many years who have no idea how that works. And then they look at it and they go like, oh, I just saved a lot of work. It can help you in a lot of scenarios. Just this one here, local root Postgres, we get a lot of those people who say, I'm sure you've run into it. People are used to being able to log into anything as long as they're root. And they can't log into Postgres as root, and they get really annoyed. This is how you fix that problem. Just tell them root is actually allowed to do it. Now you still have to specify which user you're logging into. So if I'm, in this case, logged in as root and I just hit PSQL, it's going to try to log in as root because the client can't see this file. But what I can do is I can say PSQL-u Postgres. Or I can export the variable PG user for my entire session that every time I type PSQL, it's going to use user Postgres instead of user root. But by default, it picks up the local username because the client doesn't see the identifier. That mapping happens only on the server. It only tells you who you are allowed to log into. It doesn't make you log in as that user. Okay. There are a bunch of more authentication methods. I'm not going to go through them. You can go play with them yourself if you want. These will cover almost everything that you really want to use. If you come up with some other interesting ones, let's add more of them so we can be even even more better. So I'm going to leave the part where we configure the server and look a little bit more at the application side for a short while. And of course, application security itself is a gigantic topic. We can spend unlimited amounts of time on that. We could probably spend a day talking about just like the new row-level security features, or just all the different kinds of permissions you can set. So I'm not going to do that. Instead, I'm going to just stick to a couple of tips, maybe a little bit of the Postgres-specific things, and an example or two, and just try to not cover everything, because there's a limit to what we can do. Now, probably the first and most important tip, and really ignoring all the things we said earlier as well, the most important thing, if you're going to remember one thing that we said in here, the one thing that's the most important, don't ever use the super user. Like ever in your applications. Just don't. Using the super user disables all security in Postgres. The super user bypasses everything. It's like you don't run your web server as root, right? Right? Okay, who did? Some of you might do without knowing, but I mean, we don't do that, right? Pretty much every permissions check in Postgres starts with an if is super user return true. That's sort of the basic pattern of coding. There's no way to protect against the super user. In fact, the super user can run arbitrary code on your server by design. The super user can rewrite your configuration. For example, rewrite your PGHPA and turn off logins and things like that, and make the whole world trusted. The super user can do all that. And that's by design. That means you should keep the super user really restricted. Preferably, you shouldn't give it to anyone. I like to configure systems where like the normal DBA work still is not done as super user, right? Because it's also very easy to typo something and everything is just gone, right? It's dangerous. But what you should absolutely not do is let your application or your end users run as super user. And it's unfortunately the trend since many years back when we got the ORM toolkits that like to manage the schema for you and create all your tables and things. If you go far too many of them, you go read the documentation, they say just make sure you create the user as super user because then everything works. Like, yes, but not in a good way. Like, yes, they can then create and drop them whatever, but that's not actually a good thing. Right? So you should never ever see your application run as super user. Now if you can also restrict the things you do yourself or the things your colleagues do, that's probably a good idea. If you want proper security on the super user, make sure that that user, for example, if it's the user Postgres, can only log in over peer using Unix socket, because that means that the user is already logged in as super user when he logs in as super user. Right? If it's the user Postgres on the operating system, then that's the same user that can then run the arbitrary code, so it's no longer privilege escalation. And you also get, if your DBAs are logging in, you get an audit trail, an external audit trail, because you get the logs from sudo, for example, that says, hey, Magnus just switched to being user Postgres, and then a Postgres connection appeared. Okay, you know who did it. You can go beat him up later, right? So it gives you a lot of those abilities. Now the next step down, below super user, is the database owner, which you should really avoid using if you can, because the database owner can bypass all permissions in that database. Right? Even if you revoke the permissions of the database owner, the database owner can grant itself back those permissions. So in reality, you can't revoke them. Now it's still much better than super user, because the database owner can't run arbitrary code. It can't rewrite files in the file system. But you should still try to avoid it. But if you're using one of those frameworks and nobody's willing to give you the time to set things up properly, then at least switch to database owner instead of super user, because whatever ORM framework you have that's managing all your schema, it will work perfectly fine with database owner. It does not need super user. It's just that whoever wrote that documentation didn't realize that. So do that, but try to avoid using the database owner as well. One pattern that I like to set up with a number of our clients when they're using a framework, because, I mean, I'll grant you, there is a lot of point to having these ORMs manage the schema for you. It's very convenient. It's less boilerplate work, less typo mix, and things like that. What I like to do in those cases is give each application 2 users. One of them might be the database owner, and that user is only used when they deploy a new version. So basically, when a new version is deployed, you start it once as the database owner. So it runs all the DDL, creates all the tables, drops all your data, and then you restart the application with a low privilege user that does not have permission to do that. It's certainly not perfect, right? There are still many things that you can do to secure that application much better. But it usually gets you pretty far on the whole trade-off scale. Like, the effort is also very small, and the increment is not that bad. Actually, I've had a lot of cases. So back in the days, who in here has ever used Sloaney for replication? Oh, okay, I'm not surprised at you guys. Okay, well, you too. Okay, so Sloaney is one of the trigger-based replications. What Sloaney does is it basically adds triggers to each table, right? And then it collects the changes and replicates those. It's what we did before Postgres version 9 when we got the built-in replication. Now I've run into almost exactly the same scenario with 2 clients back in those days who were using Sloaney and it just suddenly stopped working. And just nothing replicated, and then you went in and like Sloaney was halfway uninstalled. Is what I claimed. And they claimed, we did nothing, Sloaney is broken. Now for those of us who worked with Sloaney, it's not unfeasible that Sloaney is broken, so you actually have to check it out. But what it looked like was like all the tables just looked, Sloaney had just been unlinked from all the tables, or from a couple of them. So like, how does that happen? So you go ask them, do you guys like drop the tables and recreate them or something like that? They're like, no, we don't do that. Why would we ever do that? Like, no, exactly, why would you ever do that? But it looks like you did that. And they were very stern saying, no, we didn't do that. So then it's okay that I revoke your permissions to do that. Temporarily, of course. Like, oh yeah, sure, we don't use it. It took about 3 hours and then their application crashed because they tried to drop the tables and recreate them. And it was actually, in both cases, it was done by a framework that had some sort of trigger. Like when I've done 10 million updates in a table, I should probably drop it. It was a queue table, so it didn't contain like transit. So when I've done 10 million changes, and there is currently no rows in the table, I'll drop and recreate it to make things faster. Which of course then dropped Sloaney, so the replication broke. Right? It's a good reason why the application server should not run with permissions to do that. Especially since in this case, even the application developers didn't know that they were doing it. Right? So run with as few permissions as possible. In this case, what we got them onto eventually, since by removing that permission made them not be able to deploy new versions, even when they fixed this bug, was exactly onto these 2 accounts. One user for making schema migrations, another user for running the actual application. It's at the level of effort that they would accept for something that increased both security, in their case also, stability of their system, because they can keep breaking the replication. Another thing, if you go one level deeper into Postgres that we can use a lot, is using schema boundaries and permissions on schemas, which is something I think a lot of people miss out on in Postgres because they're used to other systems. Like if you're coming in from an Oracle system where a schema and the user is the same thing, if you're coming in from a MySQL system where a schema and the database is the same thing, or things like that. In Postgres, the schema is a completely separate object that is just a container object. It doesn't actually represent anything other than it contains stuff. It contains tables, it contains views and functions and all sorts of things. But it's also a container that we can put permissions on. Now a schema only has 2 permissions. It has a permission called create, which if you have that, you can create things in the schema, like tables and functions. But the interesting one in this regard is the usage permission. And it's really more interesting what it means if you don't have it. If you don't have usage permissions on a schema, you can't do anything with any object in that schema, regardless of the permissions. In fact, you can't even do it if you're the owner of the object. If you don't have permissions on the schema that it's in, you can't get in there. Now, if you have usage on a schema, then we'll go ahead and check the object level permissions. So then we'll go ahead and check, do you have select on this table? Do you have insert on this view? Things like that. But it gives you a way to subdivide access in your database in like bigger chunks without having to maintain individual permissions on every table, if you need to do that. It also gives you sort of a safety net if you know there is a bunch of tables that are sensitive that only a few users should ever have. If you put them in a separate schema, put the schema permissions, then if you at some point forget or make a mistake when you set the permissions on the table, nobody's ever done that, but this is going to be first time, then you get that for free. Right? You get a safety net against some of those things. There are other good reasons for using a schema, since you can just group your objects in a more accessible way, handling search paths and things like that. So there are other reasons to use it, but from a security perspective, actually having this sort of ability to set permissions on a block of tables can be very useful. You can also use it to temporarily restrict access to a schema without having to change the permissions on all tables. Say, oh, I'm upgrading this application that lives in its own schema, so I'll just kick everybody out of that schema for a while without touching any permissions. When you're done, add the permissions back, and you're good to go. So it's one of those boundaries that exist in Postgres, and given that our schemas are lightweight and just container objects, we can do a lot more with them, even though this is very simple, than you can do in many other systems. So having gone through those, I'm going to switch over to do an example of something where using the right tools out of Postgres can help your application a lot. So who in here has ever built or been part of building a web application? Yeah, I figured as much. That users log into. Yeah, okay. So that's sort of most web applications today, right? So what I'm going to look at the scenario of password management in web applications. Today in most web apps, it doesn't matter what you do. You probably collect a lot of sensitive data. A lot more than this, but everybody will collect the username and the password and email, right? We can argue whether those are sensitive. Well, the password is probably sensitive. Hopefully you hashed it, but it's still a sensitive thing. The email address can be surprisingly sensitive, given how much people pay for verified email addresses to send them spam. But you also probably can add a bunch of columns here that you're collecting that it's really bad if they get out. I'm going to keep these ones for the example. So we have this bunch. We're successful, we get a couple of 100,000 or millions of users, we collect all this data, and then what typically happens? Like, it's a web app, right? But we collected data. What's going to happen? We're going to get hacked. Right? It's what happens. In fairness, it seems to be only a matter of time. Like, it no longer makes the mainstream press when someone does that, because it happens so often. And people hack them, they dump all your data, and they get all your users, and they get all their sensitive data, and all their passwords, and all that stuff, right? Didn't we solve this? For one thing, who in here stores passwords without hashing them? Okay, that's good. It's at least something. It would be embarrassing if you did. People still do. But the thing is, that only protects the password. And there is a lot of other interesting things in here. And even after we all use hash passwords or whatever password manager thing we have, people still get hacked. Now the hash passwords help for a few things. They help, for example, if I get a dump of all your 10 million users and they're using the same password in different sites, I can easily reuse them somewhere else. Like if they use the same password for your site and their bank, or if you're the bank, another bank. Right? It protects against that. Now people shouldn't do that, but we know that people do that. So hash passwords are still very useful, but the fact that we can dump it in the first place still allows me to make an offline attack. And probably some of your users, maybe one or two has a bad password. I've heard it happens. And if I get 10 million users from you, you bet I'm going to be able to reverse engineer some of those passwords and use them somewhere else. And I also get things like, again, leaked email addresses are actually valuable. People will pay for that when they're verified. It's a nice black market for that. Valuable makes it a target. People hack systems just to get to that dump and to send it somewhere or to sell it somewhere. And if you're collecting other personal information, please don't store your credit card numbers in clear text. that seems to be, actually, it kind of surprises me. Whenever someone gets hacked, they get a dump of 10 million users, the only thing that goes out in the press release is, we don't think they got any credit card numbers. Like, yeah, I sure hope they didn't get the credit card numbers, but what else did they get? You might store, a lot of personal preferences, information about people that they don't necessarily want leaked. In a lot of cases, maybe they don't want people knowing that they're one of your customers. It really depends on what your business is. I'm sure there are a lot of businesses where the customers don't necessarily want anyone to know. In particular, they might not want the tax agency to know that they're your customer, right? So this is all actually a problem, and the thing is, we can easily fix this. There's really no reason today why anyone through an SQL injection or anything like that should ever be able to do bulk download to get all your users. And the database can help you do this in a couple of simple steps. So again, let's take a look at this sort of atypical web app that does something. You have something in our valuable table called users. Yes, it's going to be more than one table. It's going to be a bit more advanced. You might even have like a unique index of username, for simplicity's sake, we have a user table. It's user ID, password hash, and email. We're smart enough to use password hashing because we've left the 90s. But then when someone hacks our database and gives us a nice SQL injection attack, what they end up doing is something like select star from users, and they've got all your users, and all the password hashes, and all the emails. So they get the hash passwords, which they can do an offline attack on. They get all the emails that they can sell on the black market, and they're all happy. Now, does this general problem remind you of anything? Anyone seen this before? If we're talking about outside of databases, so this is a scenario we recognize that used to be a big problem. Like if we go back to, who in here was actually maintaining and running systems prior to 1990? Nobody? I don't believe you. I'm looking at least at you, you certainly did. So back in those days, we actually had this problem with this file. Right? We still have this file, we don't have the problem anymore. But the problem was, etc. passvd on every server was readable by every user on the system, like your SQL injection attack just made your table, and it contained the hashed passwords. It also contained hashed passwords with a pretty weak hashing algorithm, but that was because it was, the 80s and things like that. Now, we solved this problem in the 90s. Well, I was certainly not part of doing that, but, I'm reaping the benefits. We implemented, or the world implemented, something called shadow passwords. This, I had to research this for this talk a previous time. It was invented in 1988 in System 5 version 3.2, and it entered Linux in 1992. That's a long time ago. Why are we making the same mistake again? Because it is actually the same mistake. Like, we're letting people download our sensitive information in bulk. That's pretty much what we did with this file. So we fixed this with shadow passwords when it came to users. So can we do the same thing in the database? Turns out we can. If we look at how a shadow password system works in Unix today, you got etc. passvd and etc. shadow. The passvd file is basically a view. Has the same data with all the sensitive stuff stripped out. But we still need that data, because when I do an ls, I need to figure out which user owns a file, for example. So I need the usernames. They're public information. In our database, I can't just remove all access to the users table, because there are probably foreign keys pointing to it. You need to be able to look up other users, like the application needs to be able to do those things. But we have the concept of creating these views. In Postgres, we even call them views. And shadow passwords also rely on the fact that anyone who's actually logging in uses setuid binaries, so that they temporarily can go look at the password and then go back. Turns out we have that too in Postgres. So we have all the parts that we need to solve this problem. So, going back to this is the basic problem. My non-privileged user can run select star from users, and he can get the username, he can get the hash, and he can get the email. These are the things that we don't want. So if we just go replace this thing with view instead. So what I'm going to do here is I'm going to take my users, I'm going to rename it to shadow, and I'm going to revoke all on shadow from web user. So now the web user can no longer see anything. That's good. Except it's also kind of can't really do anything because there are no users anymore in my system. What I do then is I create a view that has the public information. So in this case, it looks exactly like users. So I get the user ID, but I'm going to make the hash null. I'm going to make the email null. And then I grant the web user permissions to view that. I can do this through like column level permissions and things like that as well. But this makes it, unless the application is actually trying to figure out, looking at the system table, whether this is a view or not, they're not going to notice the difference. Still does a select star from users, it just comes back in the same structure, but all the sensitive fields are now null. And if the user tries to go from shadow immediately, well, permission denied. Right? And from users, I get the username, but none of the sensitive information. So that's pretty good, except nobody can log into our website now. But they also can't download our data, so you know it's a trade-off, right? Are your customers going to be upset if they can't log in? Maybe. So the thing we need to do is to implement this shadow password check inside Postgres. To do that properly, we need an extension. It's an extension that ships with Postgres. It's in the contrib package if you're installing from RPM or something like that. And it's called pgcrypto. So we just say create extension pgcrypto. pgcrypto has a bunch of different functionality. You can do things like GPG encryption, stuff like that. But the things that are interesting here is it provides a very interesting function called crypt. This is a dual-use function that can create hashed and salted passwords, and it can also validate hashed and salted passwords. It supports a bunch of different algorithms for doing it. You can use DES or Blowfish or bcrypt and all those things. So we combine this, and then we combine this with what we call a security definer function. This is like a setUID binary. It can give you really powerful access control if you use it right. It can really shoot your foot off if you use it wrong, so don't use it wrong. And in this particular case, we need to create a login function. It's going to look something like this. So this is a PL PGSQL function. We just say, create a replace function login. It takes a user ID and a password, and it returns an email. Obviously, if we had more sensitive fields, we'll return those fields as well. That's just a list of what we're returning. And we say returns text, and we say language PL PGSQL, security definer. That's the part that makes this one run as a setUID binary. So if we just say create function, and then the web app user runs it, the function will run as the web app user. But if I add security definer, the function will run as whatever user owns the function. Please make sure this is not the super user. Otherwise it runs as super user. It runs as someone, but it runs as someone that has permissions on the shadow table. And then what you do here is you say select email into email, that's reading it back into the return parameter from shadow, where shadow user ID, I'm doing case insensitive username matching. And then we say and the password hash equals the crypt value of the password and the password hash. Now this is where pgcrypto has this interesting interface to the crypt function, but the crypt function basically says if you call the crypt function, passing it the password and the password hash. If the password is correct, it's going to end up returning the same hash. So basically this is if the username and the password matches the username and the hash password, it will return the email. And it works. If I put in the wrong password, I get null back. If I put in the right password, I get my email address back. Now this gives us a couple of things. First of all, the only way to get the email address back is if you already know the password. And you can't bulk dump anything. If you need to dump 10 million users, you need to call this function 10 million times. Each one with the correct password. So it sort of solves those problems. Now it gives you a little bit less flexibility, but most of the time it gives you enough. Now it's not enough to just have a login function. We're also going to have a change password function and a create user function. All of those things need to be put as a functional API inside the database. But I've done it several times. It's fairly easy usually to adapt the like the frameworks of your typical web application, whether you're using Rails or Django or whatever, to adapt them to actually call these functions instead. And it lets you keep the users in the database in the standard structure, so that all your foreign keys, all your regular queries still work as long as they don't try to access the sensitive data. Now there are a few things to, let's say, beware of in this. You can get SQL in SQL injections. It's kind of fun. I've seen it happen. I've never seen anyone attack it other than myself to prove a point. But if you, for example, in this function, let me go back to it. If you in this function do, SQL concatenation, then you can actually SQL inject into your function, which of course then runs as a high privilege user. So every security definer function that you create in your system becomes part of the attack surface. It is somewhere that you can escalate. This is the same thing as every setuid binary on your Unix system is a target for a hacker, right? Because it will increase its privileges. So if we can make it do something that the author didn't intend, then we can do interesting things. So we don't want to do that. It can let you do things like unbounded data access. Once you're inside the function, you can dump the list of users. So in theory, you could concatenate all the email addresses and return them as one text field. Right? As long as it's less than a gig, we got it working. Otherwise, you're packing it. Which is why, again, never create a security definer function as super user. Because every time someone executes that function, it will now run with super user privileges. Of course, that's a never, except when you actually have to use super user. There are things where you might need it, particularly today in Postgres in the monitoring aspect. There are things like you can't do from a monitoring perspective unless you're a super user. Well, then you have to do it. Right? But for other cases, don't do that. And it goes back to the whole avoid using the database owner as well. I'd like to recommend you create a separate role just for this. So in this system, you might have a role like login manager that owns these functions and that acts as the arbiter of this interface. And that is the one that takes care of that part. Just to keep things clean and to keep things separated. I mean, there are many examples to things where you can use these sort of application level functionality in Postgres to enhance your security. I think this is a fairly straightforward one. It's a fairly simple one. It's one that many more people should implement. And in fact, if any one of you happens to be working on one of these web frameworks, you should build that into the web framework to help people use it. Because it's simple to do and it actually gives you quite a bit. I think I'm approximately half an hour early, based on the latest time, but since there is no end time, I'm just going to cut into the summary and then invite you guys to a short discussion at the end. But a short summary of what we've been through here is really, whatever you're doing when it comes to building this security, you need to start with this. You need to start by determining what your requirements really are. And unfortunately, that may be the hardest part. To figure out what actually makes sense. And you need to determine the trust levels. Do you trust Amazon? The answer is no, don't deploy on Amazon. Do you trust your local co-location services? If not, well, then you're going to have to build yourself a data center. Right? It's all a matter of that. What is your actual attack surface? Which parts of your system can people get to? And what are they interested in? Where can they come from? Are you in a secure building? Are all your cables inside of the secure building, or do they actually go outside of it and come back? I'm sure that can happen. Determine those parts. And then deploy the correct countermeasures. Don't deploy all of them. Because there's no way you're going to be able to manage and handle all of them. So make sure you use the stuff that actually makes sense. Checkbox featuring on security features is completely useless in the best case. Right? It's like that, say, well, the standard says you have to encrypt the disks. Okay? But it doesn't say anything about what you do with the keys. So you put the keys right there. It didn't help anything. It just made things more complicated, made them more error-prone, made them slower, and didn't win anything. Except maybe some people actually think your system is not secure, which is dangerous. It's better that they realize that it's not. One of my other favorites there is the Md5 Authentication, where people were like, well, you know, Md5, it's a weak encryption, right? We all know that Md5 is broken. Except it's not really broken for use as hash passwords. And also, if you send the password and that's the only thing we protect, and then you use that password to access all your really expensive business critical data, and we send that in clear text, does the fact that we hashed your password really help that much? Assuming you're not using the same password for other things. If connection security is actually a potential problem for you, you need to use encryption of the whole connection. You need to use SSL, you need to use a VPN, you need to use IPsec, you need to use something like that. You can't just trust the MD5ing of your password for that. It's not going to help you. And remember to lock all the doors. That's the classic again. Why bother encrypting the data if you're storing the keys right there? Do you bother locking the door at home and then leave the key in the lock? I should add intentionally. I'm sure it's happened unintentionally, but you know, intentionally you hopefully don't do that. Sometimes you leave it under the mat. That's a very easy way to hack into that system. I guess that's equivalent of using a standard password or something like that. Why go through the gigantic cost of deploying a smart card infrastructure throughout your organization, and then you send all your data in clear text across the network? So someone can just sniff it and not bother hacking you. Right? Figure out what the right places are to secure, and secure those, and just ignore the rest. Because deploying all of these things becomes, from a management perspective, very, very expensive. So pick the ones that actually make the difference. And I say, I mean, the fact that a firewall doesn't protect you does not mean you shouldn't have one. Right? The cost of deploying a host-based firewall and a network-based firewall is close to zero. So not doing that is just stupid, frankly. Just do that. But don't think you're done. I mean, that's a fairly classic argument where people say, you know, oh, our system is secure, we have a firewall. Like, yeah, it doesn't work that way. Once you're through the firewall, it tends to be everything is just wide open. You can jump from system to system when you're hacking. You need nice layered security. We here read, I don't actually know if I read the end of it, but there's something in the, was it German Parliament a couple of weeks back? Who had some malware enter their systems through the firewalls, through all the other stuff. And they were looking at throwing out and replacing all their computer hardware because they were unable to get rid of it. They cleaned it and then it came back. And then they cleaned it and then it came back. They don't know where it came from. That's the kind of, I have no idea whether it applies to their specific scenario, but that's the kind of thing that can easily happen if you only have a perimeter security and nothing behind it. Because once you get in, you can just hide anywhere and sort of come back, pop up. It's really, really hard to clean something like that up. So make sure you have security in multiple layers, otherwise it doesn't get there. And then a few of those things that are just, you know, too simple to mention, like don't use trust. And no, not even in testing. The main reason for not using it in testing is, well, there are two reasons. One of them is someone can log in as super user and run arbitrary code on your machine. You don't want that even in testing. And the second one is you're not testing the thing that you're going to put in production. You should test the same thing that you're going to put in production. That's sort of the point of having a test. And use PGHPA. Like, don't go in there and just create the one line with 0000/0. Like, please don't do that. I know it's easy. Of course, also don't go overboard the other way and create a 5,000 line version of PGHPA. Because if you do that, I can promise you that somewhere in there is a wildcard rule or an opening rule that you forgot about. Like, keep it at a manageable level. But even like, you know, 50 to 100 rows, easily manageable, but usually 25 rows is enough to quite drastically increase the security of your systems. And it's so easy to do. There's no reason not to make that step. And restrict the IP address. Like, don't ever put the 000/0 in there unless it ends in reject, which is the implicit one if nothing matches anyway, but that's a good start. And use SSL if you have to. Right? The SSL code in Postgres works. All these certificate authentication, all that stuff, it works. It can be a bit of a pain to get set up, but once you have it set up, it does work. Now, I'm strongly against doing the thing that Debian does. It's a few times. I'm a big fan of Debian in like every other aspect than this, I think. But the fact that they turn on SSL with snake oil certificate by default without configuring it properly makes no sense. Right? So if you don't need it, turn it off. If you need it, configure it properly and turn it on. Just turning it on by default basically means you're paying overhead and you don't really know why. A default installation of those Debian will, for example, encrypt all the traffic over localhost. Because who's going to sniff your localhost? Like, again, that means someone already owns your local OS kernel, in which case you've lost. There's nothing you can do from the Postgres layer if that has happened. And of course, remember that security is an iterative process. You're not done. Like, you're never done when it comes to doing security. The requirements will change. The entire landscape will change. The attack vectors will change. You need to not just be secure, but actually manage to stay secure while looking through those things. Take your 5,000 line PGHBA and go through it every now and then and see like, whoa, where did that come from? Or, why is this thing set up like that? Why do I have 25 SSL certificates that have been issued to the same server and none has been revoked because someone reinstalled the machine and got a new cert and didn't revoke them properly and things like that. It's all about coming back and going around iteratively checking the system. You're never done. So that's all I have for planned content, but I'm happy to take discussions around either any of the security-related features that we talked about here, or any of the other security-related features in Postgres or in databases in general. Or I guess, if we end up with nothing on that, anything related to Postgres is open game at this point. Everybody just wants to go home and sleep. Everybody just wants to go to the pub. Yeah, that's... oh, do you want to go to the pub, or did you have a question?
No, I have a question.
Okay, shoot. Do we have a microphone for you?
I don't know.
Okay, you can yell.
Yes.
Or I'll repeat the question.
What would you advise to implement some kind of auditing in Postgres? Just put triggers everywhere, or something smarter, or just not do that and rely on external auditing like this pseudo.
So what would I suggest to implement auditing? It really depends on what you need to audit, unfortunately. I mean, Postgres does not have very capable built-in audit functionality unless what you're interested in is who logs in and who logs out. Because there are two parameters for that. There's log connections and log disconnections, which actually gets you reasonably far. If you need to audit modifications in the database, you basically have two ways to do that today in Postgres. One of them is triggers. If you do auditing with triggers, you want to combine that with security definer and the schema boundaries. So basically you create an audit schema that only one audit user has permissions and nobody else. And you put your audit data there. And you make your audit trigger security definer to this user. So that if I make a modification in the database, I can't even see my own audit trigger. I can see that it will appear, but I can't look at it. I certainly can't delete it. And then you get your audit data in the database. There is obviously a non-trivial amount of overhead to doing this, so it depends on how many updates you're taking. I think the other interesting take that I've seen people work on, like more application-specific ways of doing it, is if you're on 9.4, using the logical decoding functionality that's in 9.4, like basically a logical replication target that instead of replication does auditing. I don't think there is a tool out there that will do that in the generic way yet. I know people are working on it. I've seen people deploy that in like application-specific auditing that knows about the data structure and does that. An advantage of that it has much, much lower overhead. It's not zero, but it's not very far from zero. Those are sort of your main ways of auditing that. Now, if you need to audit people reading the data, then it sucks. It also depends on what you need to audit about the people reading the data. You might end up even doing a full query log might not be enough. You might need to log the actual data, in which case you need to do that at a different layer. If you're interested in that part, or actually in the whole audit trial thing, I would suggest I have a talk tomorrow as well. It's about time travel. It's somewhat related to that. So I'd suggest you come to that one. I'll go through some of the other things that you can do around that to work around, but that's not for generic solutions, but for a specific customer case that we have, which is sort of auditing related. Okay. Yes?
Is it possible to launch users in PG file when they are authenticated by certificates, not only by CN field, by other fields of certificate?
So is it possible in PG Ident to map users based on fields other than CN in the certificate? No. Unfortunately, no. Only the CN certificate. I know there's been discussions, I know I've had discussions with clients about the ability to at least add like a filter field to the HBA. You could then have multiple rows in the HBA that would do that, but it's nothing that's, I know, has been implemented yet. I certainly haven't done it, and I haven't heard of anyone else doing that either. Yes?
What is the default hashing algorithm in Postgres?
The default hashing algorithm in Postgres for what? I'll have to ask.
For store users' passwords.
Okay, for the store the users' passwords themselves is Md5. That's the Md5 authentication methods. Now, if you're using PG Crypto for the storing them in a user table, there is no default. You have to pick one.
Why not bcrypt or?
Why not
Md5 by default?
Yeah.
Why?
So, I mean, the main reason is, one thought is if you can actually steal the system table containing the password hashes, you can steal the whole database anyway. Now, that said, there is work in progress on implementing other things. The part is that part of the Md5 is actually part of the authentication protocol, so we can't just change it transparently on the server. It would invalidate clients. So we're looking at fixing that possible with a whole new level of authentication for username password that will be more secure. So we'll get there, but we're not there yet.
Did you fix the problem with challenge response authentication? Pass the hash problem?
Yeah, so no.
No?
The fact is, if you can steal the password hash, then you can use that hash to authenticate. But you can also steal the rest of the database.
Okay.
So you don't need to authenticate. But no, that's one of the many things that sort of stirred that it's time to work on the next level. Because that is based again on the protocol level, things that we can't fix that without breaking compatibility. And before we break compatibility, we need the new solution, and we'll make sure the new solution is future-proof, so we don't have to break it again.
Okay, thank you.
Thank you. Anyone else?
That's all.
Well, in that case, I shall release you. And I guess I'll hopefully see most of you again tomorrow at the actual conference. Okay. Thank you for showing up.